Hi, good morning and good afternoon. On behalf of Vortex, I welcome all of you for today's webinar. The topic for today's webinar is high resolution wind resource data. Okay, let us start with this equation. So high resolution data versus coarse resolution data. Okay, maybe I have not put this sign. Maybe I have put this sign as a wrong sign because our CEO Pep Moreno, he always says that wind analysts either need large extensions or high resolution wind resource data, but he never needs both at a time. Okay, so these two data are not competing with each other, but they complement depending on the stage of project development. Anyways, in today's webinar, we will be discussing about high resolution wind data. Okay, we will start with the introduction and I will be explaining what technology we use in Vortex, then the 10 minutes time series data, then the extremes, gap fill tool, and at the end, I will show these products on our interface. Okay, so let us start with the technology. So what technology we use? We run work model, and you can see the main input for the work model will be the macro scale reanalysis data from ERA5, CFSR, MERA2. Then there will be another inputs, terrain from SRTN that will be at 100-meter resolution. Then the roughness from globe cover, which will be at 300-meter resolution. So we ingest all these three details in a WRF, and we run WRF to downscale this macro scale information to mesoscale level. At mesoscale level, we are delivering wind maps and hourly time series data. Then we are further downscaling this mesoscale information to microscale level, and you can see at microscale level the products will be farm, LES, blocks, and extremes. Okay, suppose if we have to categorize these products in two different categories, we can categorize as products, those are giving information for area, and then the products, those are giving information for a single point. Okay, usually for the prospection purpose, when we need information for area, maybe the large areas like states or countries, or even for continents, we can go for the wind maps at 3 kilometer and 1 kilometer resolution, which we are using for the prospection purpose. Okay, and then once we identify some specific areas with high potential high potential, or some spots, we can launch high resolution farm WRG files where we can calculate up to 1,500 square kilometers area. The output will be WRG files. The resolution is 100-meter again, and we can import these WRG files directly in AEP tools, maybe OpenWind, Wind Pro, etc., for feasibility or for the design, even during the designing of wind farm. And then when we want to know the long-term trends of any location, we for that particular point, we can go for hourly time series data. We are providing 10 years, 20 years, and 30 years hourly time series data, which will be downscaled at exactly to client's location, and from based on MERA, CFSR, or ERA5. Okay, then these are again high resolution products. Those are giving information for a single point. So when somebody needs wind distribution tab files, he can go for a virtual mast from Vortex. Then the LES 10 minutes time series data and extremes, these products we will be discussing in detail in today's webinar. Okay, so the products above this line, they are giving information for the single point, and then the products below this line, they are giving information for area. Okay, let us start with the LES 10 minutes time series data. So have you ever thought to have a 10 minutes time series wind data, that too without installing a MetMast and without waiting for a year? Okay, Vortex LES gives that possibility, and probably provides the most measurement like synthetic time series data, which today's atmospheric models can achieve. Okay, so before going in detail about LES, what is the use of these 10 minutes time series data? So I mean the applications of the 10 minutes time series data. So whenever you need turbulence information for any location, you don't have measurement, you can go for LES, and LES gives the turbulence information. Okay, so usually in the wind farms, we know that with micro tools, either it be linear or CFD tools, we usually collapse the long-term calibrated data in wind distribution tab files, even sometimes in Weibull, and then we extrapolate this tab file information to each of these WTG location. Okay, but many times we think that to have a time series information at each of these WTG location, maybe for performance assessment of individual turbine, maybe load calculation, even for designing the foundation of that particular turbine. So all these applications we can go for LES, and with LES we are able to have a time series data on each of these WTG locations. Okay, then the offshore locations, because we know that it's not that easy to have a permissions to install a met tower in offshore location, and of course the cost component, I mean. So we can launch several LES runs in these offshore locations, and maybe once we know these are the few locations, maybe 1, 2, or 5 locations where we can think of installing a met tower. Okay, then there is another application, filling the gaps in a measured data. So in this webinar at the end we will be talking about gap fill tool. Okay. So then for you can see for such a complex scenarios, we do the measurements, but measurement don't represent the large area. The measurements are very local, or they are particular point specific. So usually we can launch several LES runs in such a complex area, maybe for each of the proposed wind turbine position, and we can use that information for the AEP calculation. Okay, even we can launch the LES run at the metmast position to check or to validate the LES output. Okay, so these are the applications of 10 minutes time series data, and let us discuss about what exactly is LES. So LES is nothing but large eddy simulations, and it's a CFD code of WRF. So now it's time for polling question. Okay, so already some of you are aware about LES time series data. So let me ask, what is the sampling rate of LES? Whether it's 10 minutes, hourly, 4 hertz, or 3 seconds. So I request all of you, please answer. Patricia, can I have answer for this question? Okay, so the sampling rate, most 67% they are saying the 10 minutes is the sampling rate. Some maybe 14% saying hourly, 10% are saying 4 hertz, and 10% are saying 3 seconds. Okay, let us discuss answer in this slide. Okay. Okay, so as I told, LES is large eddy simulations, and how exactly we prepare this 10 minutes time series data. So we use initially WRF to downscale this macro scale information to mesoscale level at 1 kilometer resolution. And once we reach 1 kilometer level, we introduce Vortex WRF LES or Vortex LES to downscale this mesoscale information to microscale level at 100-meter resolution. Okay, and important here is the seamless coupling between this mesoscale and microscale. And thanks to our R&D team, they are keep on updating and working to update this LES code, and that is the reason I say it is a Vortex LES, and so that to make it to optimize it on the computational power use, for the in terms of, and to make it commercially viable in terms of delivery and in terms of cost. So how exactly this data looks? Data exactly looks as a metmask data. So you can see there will be a date, then the time. You can see the time step is 10 minutes, so same as the metmask data. Then there will be mean speed and wind direction column, also the standard deviation for mean speed, standard deviation for direction, 3-second gust, temperature, pressure, Richardson number, and vertical speed. So data will look exactly same as a metmask data, and by default we are delivering 1 year of data. Then user can decide which 1 year period he want the LES data, maybe for 2019, maybe 2017, or June 2015 to June 2016. Okay, this is one concept. There is another thing. Suppose we are delivering the long term year also in case of LES. So either user can decide what 1 year he want, or he can go for the long term year. So what is the long term year concept? Okay, so you can see initially we launched the Vortex series at 3 km resolution for 20 years period, and then the tool makes 1 year window, and it moves that 1 year window to search the representative 1 year period for that particular location. So you can see on this location, this is the 1 year period from 2008 to 2009, and it should be a consistent 1 year, because we have to calculate the turbulence and all. So period should be consistent. And once we know this 1 year consistent period, which represents the long-term wind for this particular location, we can introduce WRF LES to downscale this hourly information to 10 minutes time series information. Okay, and then comes the validation. So I tried to launch, I had launched LES run at Nive Lidar, because I can see my colleagues from India. So they already know that there was a LIDAR measurements in Gujarat offshore location. So I had launched LES run on the same coordinates. So you can see the results. Average speed recorded by LIDAR, it was 7.34 meter per second, and average speed given by Vortex LES, it was 7.29 meter per second. So there was a very less bias, just 0.7% on the negative side. Okay. At the same time, I also tried to carry out 10-minute hourly, daily, and monthly correlations for wind speed and wind direction. Okay, let me tell another validation which we did for LES on 28 sites in Vietnam. So the results are here. The average percentage bias was just 0.58%. Then the average mean absolute error on this 28 site, it was about 5%. You can see hourly, daily, and monthly correlations. And then as we are talking, the turbulence is the another important wind matrix, which is the output of LES. So we tried to validate turbulence in different terrains, in forest, in thermal affected site, even in the offshore locations. And we saw that the turbulence is validating in a really good way with the actual measurements in different terrains and even in climates. I mean, okay, not only these 2-3 validations, but you can go on our web page and you can visit knowledge center section for there are several another validations. Maybe you will find some validation for your area also. Okay, let us talk about extremes. Okay, we always go to extremes to help our users, and this time literally true. Okay, so how exactly we try to get the extremes information? Usually with the metmask measurement, the data logger records 3-second rolling averages, and it has recorded such 600 samples, and then it search for the maximum value from these 600 samples. Okay, and then it records this value as a gust for that particular 10 minutes. Okay, this is the correct way, but the limitation of this way is the period. I mean, usually we have 1 year or 2 years of measurement, and it might be possible that the extreme event might not happen in that particular period. Okay, then the wind analyst tried to search the extremes information in a long-term model data. The problem with the long-term model data is they actually don't have exactly the extremes information, but the maximum wind speed uh, for that particular hour. And then we try to calibrate this long-term information by using metmast information. And we know the limitations of MCP tool, maybe linear or matrix method. Usually these tools are focused for the calibration of mean speed, and extremes is far away from the mean speed number. Okay, then we have come up with this product, which is we call it as a extremes. And what exactly we do in these extremes? So we try to search 6 potential candidate days for the extreme event in these 30 years. So we will be having 180 days, and we will use WRF LES technology to downscale these 180 days information in 10 minutes time series data. Okay, and of course, we are calibrating this 180 days information by using metmast information. But this calibration is very focused to the extremes information. So what exactly we do? Suppose we have a measurement for a 1 year of period. For that particular 1 year, we launch maybe 100 or 150 days of LES data, and we try to search the hikes between the gust measured in the metmast, recorded in the metmast, and gust given by the extremes product or the LES. Okay, and then we measure these hikes and we calibrate 180 days data. So we have this calibrated 180 days 10 minutes time series information for that location. Okay, then that is the main input, and we use this information to prepare the extremes table for 30 years. So you can see here the extremes number, year wise extremes number, and then by using this table we are preparing a 50-year return period gumball fit. Okay, so we are providing this 180 days complete information plus this 30 years extremes table and the gumball fit for 50-year return period. Okay, and important in this case is that not only the for the to analyzing the extreme event damage, or to preparing the or designing the foundation, or for the load calculation, not only extremes number, but the important is that as we are giving 180 days complete 10 minutes time series data, we are able to know how the extreme event evolved on that particular day. And then the important is the wind shear during the extreme wind conditions, even the turbulence during the extreme wind conditions, the density. So all these metrics are important. If we know this in advance, we are able to calculate or take care the things properly while designing the foundation, or while even designing the turbines. Okay, so and in addition to this, we are also providing the report, the complementary report for prepared for the hurricanes and typhoons passed from that location. And there will be these 4 categories. So the typhoon, hurricane, cyclones which were very fast, maybe above 30 meter per second, those were very close, less than 50 kilometer. Then the very dangerous, maybe less than 25, above the wind speed above 25 meter per second and less than 100 kilometers, and there will be a higher category. Okay, so we already discussed about 10 minutes time series data, about the extremes product. Now discuss about the gap fill tool. So gap fill is not a product. Gap fill is the feature of LES data. Okay, so let me usually in the measured data, we know that maybe for several reasons, maybe for sensor failure, maybe for data logger failure, the battery issue, or stealing or something. Because of many issues, we usually have gaps in a measured data. So this gap fill tool helps to fill these gaps in a measured data. Okay, so Patricia, it's time for the second polling question. So what do you think about the gap fill tool? Gap fill tool is optimized to fill gaps with sizes. So what sizes we can fill from 4 to 20 days, 2 months, 1 to 5 days, or up to 7 days. So please, I request all of you, please answer. Okay, so from 4 to 20 days, 19% for 2 months, 19. So more people saying that up to 7 days, 38%. So I will answer this, but let me go back and please, and I had not answered about these. Okay, for this first polling question, the correct answer was 4 hertz, because the LES code solves equations of atmosphere for every quarter of second. So the sampling rate is 4 hertz. So for the polling question, the correct answer was 4 hertz is the sampling rate for LES technology. Okay, so what exactly we do in this gap fill tool? So you can see here measured data with gaps. These are the gaps in a measured data. So you can see there are several small gaps with 1 or 2 days, and there are big gaps for 1 week, 8 days, or even more. So user can launch LES run for that same coordinates of a MetMask, and then he will have 1 year of LES data. So, and then of course we can use, the tool is using measured data to calibrate this LES output. So we have a calibrated consistent 1 year of LES data. And what the tool will do, tool will use this calibrated output to fill these gaps. And so user will have a gap filled consistent 1 year of data. And we will be providing a complete 1 year of calibrated LES output plus gap filled consistent series and the report of gap fill. And the answer for this the question is 4 to 20 days. So we can fill gaps lesser than 4 days, and we are also filling gaps above 20 days. But the tool is optimized to fill the gaps of size from 4 to 20 days. So you will have a better accuracy if your gaps in between these. Okay. And of course, we try to validate this gap fill tool on 40 plus sites, and you can see we try to validate on bias for bias, absolute bias, as the errors are expected on the positive and negative side. So root mean square error also important, and then the correlations. So you can see for bias percentage, you can see with LES it was 0.53 percent, and for the calibrated output it was 0.28. So the gap fill tool improves the quality of LES. Okay, so now let us see this product on our interface. Okay, now you I can see that most of you have already visited our interface, and this one is the 1 kilometer resolution map which we have calculated recently, maybe about 1 year back. So you can, now you are seeing 100-meter layer, but you can see 150-meter layer also, 200-meter layer also. Even you can see a solar resource map also. There are anomaly forecasted anomalies, and the past anomalies also. You can see there are a lot of other anomaly information also. Then you can use this tool to upload your KML or KMZ maps so that while submitting the runs. So usually you see these runs, new and free. These three tabs are there. These are already runs in my account. Suppose if we go for new, we can see there are different products like series, map, virtual mast, farm, icing, LES, extremes, and then there are products for the solar. Okay, we let us have a look on LES. So you can see in LES run, we just have to select the location. Suppose if I selected this location, then the source will be era 5. The period, as I told, it will be by default 1 year. So user can decide which 1 year he want. He can give a start date for that 1 year period, or he can go for a long-term year. Okay, and then once he submit the run, it takes about 7 days for calculation, as LES is taking long time for the computation. So it will take 1 year, and once after sorry, it will take 7 days, and once after 7 days the run is ready, we can see what exactly we get from this run. Okay, let us go for the same LES run. So user can download different height information. So you can see here for from 50 to 300 meters, he can download any height information. So at Vortex, we always calculate all heights between 50 and 300 meters. Okay, then once he submit this request, maybe in some minutes, his information will be ready. So you can see here, the information for 100 meter is already there. So user can click here and he can download this information. Okay, and let me show you about the gap fill tool. Suppose for the same location, he has a measured data with gaps, then he can upload that data with gaps, and once he submit, he will able to download the gap fill series by using the gap fill tool. So for gap fill tool, if somebody wants to use the gap fill tool, or he want to have a gap fill series, he has to launch alias run on his coordinates, and then he can use that tool. Okay, let us go for the extremes. Okay, extremes also, user has to select the location. He can write the coordinates, or he can use this map to select his location. Okay, and again the source will be era 5, resolution will be 100 meter. If user has data for calibration, he can say yes, and he can upload data here. Okay, he can mention the height and he can upload data. Okay, if he don't have data, he can say no, and he can submit his run. It will take about 24 hours to 36 hours to get these extremes information ready, and what he gets after the once the run is ready. So let us go for sample extremes. Okay, so he can download extremes report again for all heights. He can select height and he can submit. Okay, let us have a look about the extremes report at 100 meter, which is already there. Okay, so this is the extremes report for 100 meter. So we can see the location details. We can see the extreme table for 30 years period, and the extreme number, year wise extremes number, and then the gumball feet information. Okay, so and then for hurricane or typhoon report, we can see here. Okay, so this is the report for hurricane and typhoon which passed through that location. Okay, and we can see all those tables here again. Okay, let us go back again to the main presentation. Okay, so the summary for today's presentation, we already discussed about 10 minutes time series data, the extremes product, and how the 180 days 10 minutes time series is important for analyzing the extreme event damage or extreme event days. Then the information about gap fill tool. Already we saw this product and tool on the interface. So this is from my side. Patricia, if there are any questions, we can take.
Hi, yes, Dhanaji. There are some questions. Yeah. Let's start with the first one. Someone is asking, is LES able to capture complex wind behavior like thermal effects or inversion in wind profile?
Okay, it's a good question. So as I told, even its alias is a CFD code of verb, but I keep on saying Vortex alias, because thanks to our development team, they keep on working to update this code, as I said, to make it, to optimize it. and so that to capture the turbulence and sub hourly information for the wind. Otherwise, for the hourly and average information, usually we parameterize this information about turbulence and other related to gust and all that. So, and if you remember, as I shown in the validation slide, how we validated turbulence in different terrains, for complex terrain, even for thermal affected sites, for offshore locations. So yes, I mean the validation was really good in different such different terrains and thermal affected sites. This tool definitely useful to use on these such type of thermal affected sites, even for the complex terrains, for the forest areas. Yes.
Okay, thank you, Dhanaji. There is another question. Someone is asking if we have experience with extreme product, with the Vortex Extreme in Southeast Asia, especially with typhoons.
Yes, as I told, for the extremes information, maybe initial, maybe 10, 15 years back, only mean speed was important thing for the wind power development. But day by day, things are changing, and not only mean speed, but now wind direction, turbulence, gust. So all these metrics has become same important. Okay, for Southeast Asia, for the extremes, I mean extremes is important. Information is important for all the locations, but it becomes more critical for the areas those are affected with cyclones and typhoons. And already we have sent extremes information in Philippines for some clients in Vietnam, and I mean they were happy to have this extremes information and 180 days complete time series information, which they were able to validate, because everyone has a lot of data about typhoons and cyclones. So for these particular events, they have data and they were able to validate our information. So yes, we have provided and it's very important extremes information for Southeast Asia region, maybe because there are many places those are affected with cyclones and typhoons.
Sorry, I was mute. Someone is asking, do you use the exact parameterizations for WRF to obtain series and LES? If the parameterizations are different, what are the considerations?
No, can you please repeat the question?
The question is, do we use the same parameterizations for WRF to obtain series and LES?
Okay. Okay, I mean, as I told, usually for hourly series, I mean, definitely there will be some parameterizations, but for LES, we can't do much parameterizations, because we have to calculate the turbulence information and gust information, and then the code has to solve equations for every quarter of second. So with such a high temporal resolution, it's not that needed to do the parameterizations. So the parameterizations definitely are much different for the hourly series and for LES tool.
Okay. And well, someone is interested in the gap fill tool. Is someone from Energy Systems?
Yes.
I will read the question. Our direct detect LiDAR team from US are analyzing a method for filling gaps in LiDAR data availability experience due to environmental conditions such as fog and rain. We are incorporating model data from Vortex, large eddy simulation time series product, and using it to augment the LiDAR measurements. So they are using the gap fill tool. Can you discuss more about such scenarios and use of gap fill? When can we, the users can use the gap fill tool?
No, I mean, the users can definitely, even the measurements with data logger or with SODAR or LIDAR, we can expect to have some data gaps for sure. And in all these occasions, definitely we can use a gap fill tool. As I explained, simply user can launch LES run for the same location, and he can use the calibrated output of the LES to fill these gaps. I don't. You told he is from energy systems, but I mean, I think Martha, my colleague in Vortex, she already discussing something today and tomorrow, I think, with the energy team, and they are working, they are trying to validate and doing some workshop which is related to the gap filling tool, I mean, and the LES technology. So I don't know, maybe Patricia, later on we can discuss in detail with this guest, and of course we can share this Martha's meeting details with the other guest also, maybe day after tomorrow
Yeah,
or something.
yeah, sure. There is not so many time left, so maybe
Yes,
these more specific questions, like the one from energy system, we can discuss more later on in private with a phone call, for example, or
yes.
with more details per email. Let's move on with the next questions. Someone is asking if you can repeat which is the precise model to get the standard deviation.
Standard deviation, as I told, with the LES tool, we are able to get the standard deviation information for 10 minutes period. Again, with this sampling rate, for 10 minutes period, we are able to calculate the standard deviation period by using the LES tool.
Yep. Okay. You showed some validation cases. Are those for overlapping periods? If so, do you also have done validation with a long-term LES?
Yes, I mean, for validation, usually we have to go for the that specific measured period. And for the long term year, I mean, there is no validation if because we don't know what will be the long term year for my location. Okay, the tool is going to decide, it is going to check the consistent 1 year period which represents that particular location. And so we don't know in advance which 1 year period information I will get with the long term year delivery. Okay, so if we are lucky and if we get this year where we already have a measurement, we are able to validate. Otherwise, usually for validation purpose, users they order same period as a metmask data and they do the validation.
Okay, the last one. In the data gathering, we use a smaller increment of time frame, as low as 1 minute to 30 seconds. Having a smaller and larger increments of time frame, will it affect the result? Because the smaller the will it be more the smaller they will be more accurate. Or Vortex gathered information for the whole duration of 10 minutes continuously and finding the average. I guess
No, I have
this
not.
attendee is referring to the LES timestamp.
No, but I have not understood because he is saying something about period of 1 minute and 30 seconds. I mean, because with some measurements, with some instrumentation, they are recording 1 minute and 30-second information also. But with LES, we can record the 10 minutes will be the best resolution in a temporal scale for LES. So at least we are not recording information for 1 minute and 30 seconds with LES tool because of course we calculate that information because because of the sampling rate, it's 4 hertz or every quarter of second, but then we record the 10 minutes output, so we just delete that information.
Okay, well, I think we are coming to the end of the webinar. I hope you learn a lot of the high resolution versus data of Vortex. I will send you an email with this presentation and also this video, as well as some related documents that we think they could be of your interest. And if you have more questions or do you want to know something more in detail, please write us. I will send you also the email of Dhanaji, so you can send him an email directly. And I thank you, all of you, for attending today's webinar. Thank you very much.
So I also thanks all of you for attending today's webinar. I hope today's discussion about alias tool, 10 minutes time series data, extremes product and gap fill tool will be useful for you. All this information will be useful for you for the modeled wind information requirements in future. I mean, thank you.
Thank you very much. Bye-bye.
Bye.